Okay, so I'm going to be working on the progress check review for pre-calc marking period 2. So to start off with, it says solve each inequality. So when you're working out these specific type of problems, we want to try to find the zeros of whatever the quantities, the polynomial that's in the numerator or denominator. So the zeros here are going to be -7, 3, and 5. And actually there's a double up on 5, but we'll worry about that in just a little bit. So we start off by drawing a number line and placing in those zeros that are given to us in this specific problem. The next thing we're going to do is just decide on this piece right here. It says greater than 0, so which means that none of those values can be equal to 0, because if I end up plugging in -7 plus 7, that gives me 0, but I don't want it to be equal to 0 because I want it to be greater than 0. So we're going to put an open circle on each one of these. The next thing we're going to do is we're going to test each specific interval. So I'm going to test, like, let's say -8 in that section, x is equal to 0 in that section, x is equal to 4 in this, and then x is equal to 6 in that one. And then what I'm going to do here is, in a sense, I'm doing a substitution. So it'd be -8 plus 7, -8 minus 3, and then -8 minus 5, and then square that. But really what I'm doing here is I really don't care about whatever the value is. I care more about whether it is going to be positive or negative, because I want this value to be greater than 0, so I want it to be positive. So in that first section, right, -8 plus 7 would give me a negative number. I'm going to get a negative number between -8 minus 3. And then I'm going to get a positive number on the bottom, because when you square something, right, it is always going to yield a positive value. So negative times a negative is a positive. Positive divided by positive is a positive. So I'm going to put a little plus sign there. And then I do exactly the same thing. So positive for that, negative for that, and then over positive. So this will yield a negative value. Then if I do 4, that would yield a positive here. That would yield a positive here and a positive on the bottom. So that'd be positive there. And then 6, positive, positive, over positive, which would also use another positive. Now going back to this inequality, it says greater than 0, so which means I want the values to be positive. So the inequality is going to be, well, the answers are, in a sense, multiple series of answers. So it's going to be everything from -infinity to -7, union, 3 to 5, and then union again from 5 to infinity. Now remember, we're not including 5 because there's an open circle there. By the way, it is also a 0 in the denominator, which means that that value wouldn't be available anyway. Moving on, I'm going to factor down the bottom, so x plus 6 over x, two numbers that when I multiply I get 24, but when I add I get -5. Looks like that's going to be 8 and 3. 8 and 3, and then -8 is going to be, well, 8 is going to be negative. And then x plus 3. So my zeros here are going to be x is equal to -6, 8, and -3. So -6, -3, and then 8. Now this one says less than or equal to, so I'm going to actually have a closed circle on -6 because I want the top that could be equal to 0, but the other two are going to be actually open circles, because what those will do is make a 0 for the denominator, and one of the things that we can't do is we cannot divide by 0. So that's why those two are open circles while the -6 is a closed circle, because that would give us a 0 up top, which that's available to do. And then test, kind of is what we did before. X is equal to -7, x is equal to, like, let's say -4, x is equal to 0, and x is equal to 9. So that looks like that's going to give us a negative value up top, negative here, and negative here. So that's going to yield a negative value. -4, that's going to be positive up top, negative on the bottom, negative on the bottom. So that's going to yield a positive overall. 0, that's going to be positive, negative, positive. So it's going to yield a negative value. And the 9 is going to be positive over positive times positive, and so that's going to be positive. So now, going back to the inequality, it says less than or equal to 0, so that means that it's going to be in that negative section, so this section and this section. So it's going to be negative infinity to negative 6. But then we need to bracket 6, negative 6, because we're including it, and then union together with negative 3 to 8. And then we're doing parentheses for those because those values are not included. Okay, moving on. X is equal to 1, negative 2, and 3. Don't worry about the 2 in front. That's just, it's a scalar. It doesn't change the values of the zeros. Okay, so we want the value to be positive. We also want them to be equal to 0. So we're going to start off with negative 2, 1, and 3. And these are actually all going to be shaded. And then test some values. X is equal to negative 3. X is equal to 0. X is equal to 2. X is equal to 4. And then just test from here. So this is going to be negative, negative. Looks like I'm going to get another negative. So negative, negative, negative. So overall negative. 0 is going to be a negative, positive, negative. So that's going to be yielding a positive value. That's going to be positive, positive, negative. So it's going to yield a negative. And then 4, positive, positive, positive. So that's going to be positive. So we want the value to be greater than 0. So we're talking about this region and this region. So it's going to be negative 2, negative 2 to 1. Have to remember to bracket. Union, bracket 3 to infinity. And then the last one, x is going to be equal to 5, and this is going to end up being negative 2. Negative 2 and 5. I'm going to say open circle because this has greater than, and then test some values. So I'm going to test x is equal to negative 3, x is equal to 0, x is equal to 6. So yet again, since this is squared, that's always going to yield a positive number. So if I place a negative, so it's going to be negative times a positive, so that will be negative here. This will be a negative times a positive again, so that will also be negative. And then this will be positive times a positive, so that'll be positive. So where is it greater than? It's going to be 5 to infinity. That's going to be your answer. In this region. Okay, moving on to the next page, it says expand each logarithmic expression. So since ln is our specific log, right, it is log base e. We also call it the natural log. We would set it up by separating the variables. So we'd say ln of x to the 6 plus ln of y to the second. And then if there's any exponents, we bring them down in front. So 6 ln of x plus 2 ln of y. Okay, moving forward, I'm going to bring down the 2 first. So log base 7 of x to the third divided by y. And then 2 is going to still be on the outside, log base 7, but then bring down the 3 of x minus log base 7 of y. And it's subtraction because there was originally division inside the logarithm. Now the 2 needs to be applied to both the x value and the y value of that log. So you could technically write this as 6 log base 7 of x minus 2 log base 7 of y. Moving on, condensing. So you need to make sure that you have the same common base for the log. Since there's subtraction, we're going to be dividing those values together. But the first thing I do is I'm going to do log base 4 of u to the third minus log base 4 of v to the 1/2. Now also keep in mind when it's raised to the 1/2, we can also write that as a square root. So we would write this as log base 4 of u to the third over square root of v. And yes, you can also rewrite that as v to the 1/2 as well. Okay, log base 4 of x to the third plus log base 4 of y to the fifth. And then since this is addition, we're just going to be multiplying them together. So x to the third, y to the fifth. All right, it says rewrite the following logarithmic expression using base 10 or natural log. So base 10 would be just log of x over log of 3, right? Even though that there technically is no number, it is technically log base 10, or we could always do ln of x over ln of 3. And that same premise ends up happening exactly the same way. So if I did log of 5 over log of x, or ln of 5, over ln of x. And then last, log of a over log of b equals ln of a over ln of b. And those two values are exactly the same, and that's doing base 10 and natural log. Okay, it says evaluate each logarithmic expression. So the thing you need to remember here is base of the answer equals the inside if you can't think about these just naturally. So I would do 3 to the x is equal to 81. Now some people might be able to just say, oh, that answer is 4, and then kind of move on from there. But if you're still having difficulties, we can rewrite 81 as 3 to the 4th power. So it'd be 3 to the x is equal to 3 to the 4th. Both the x and the 4 are both the exponents, so x would be equal to 4. Okay, over here, set this equal to x. So 27 to the x is equal to 3. So base to the answer equals the inside. Rewrite 27. 27 can actually be rewritten as 3 to the 3rd. So I write 3 to the 3rd, and then that multiplies by the x is equal to 3. So that would also be 3 to the 1st. So we would say 3x equals 1, right? Making sure that the exponents are equal to one another. Divide both sides by 3, and x is going to be equal to 1/3. That's your answer. And lastly, so ln of e to the 2nd, I can take this exponent and bring it down in front, so 2 ln of e. And now one of these things deals with one of the properties dealing with log. If we have, let's say, log base b of b, that's always going to be equal to 1. So if I end up having like log base 7 of 7, that would be equal to 1. And ln of whatever, let's say a, is actually log base e of a. So what we're doing here is we're saying 2 times log base e of e, which is actually just 2 times 1, which is just going to be 2. Don't let natural log scare you. It's not that hard. All right, moving on. Solve each logarithmic equation. So base of the answer equals the inside is imperative for these sections. So we're going to start off by, I'm just checking the time, 12 minutes. Okay, so I'm probably going to finish up this section and then take a little bit of a break. So number 9, base of the answer equals inside. So 2 to the 2nd equals 2x minus 15. And then you completely just remove the whole log piece. So 4 is equal to 2x minus 15. Let's add 15 to both sides. So we end up getting 19 is equal to 2x. Divide everything by 2, so I get 19 over 2 is equal to x. And we could just leave it like that. We can always plug the values back in to just double check, and it should end up working out just fine. Okay, see how there's 2 logs? We can't do anything unless if we condense them together, so that's exactly what we're going to do. So we're going to say log base 6 of x minus 8, and then times x plus 8. Now from here, equals 2. So off to the side, so x minus 8 times x plus 8. We would want to FOIL this if you're not sure what the value will be. So I'm not going to spend too much time working on this, but it's going to be x squared minus 64. The 2 middle terms end up kind of disappearing. So this is actually going to be log base 6 of x squared minus 64 equals 2. So base of the answer equals the inside. So we're going to say 6 to the 2nd equals x squared minus 64. So 36 equals x squared minus 64. Add 64 to both sides, so we end up getting 100 is equal to x squared. Square root both sides. We need to make sure that we also remember plus or minus 10 whenever we do a square root to both sides. Now keep in mind, one of these is going to work, one of these is not. So the important thing to remember here is inside the logarithm, we need to make sure that we have a positive value. If we have a negative value, it doesn't work. So if I ended up placing in, like, let's say negative 10, that would end up giving us negative 18 inside the log, so that would not work. So negative 10 is actually an extraneous solution, so we would just remove it, and so x is just equal to 10 for this problem. And yet again, you can always double check that. This will be a problem that actually works. Okay, letter C. I'm going to make sure that I have the same common denominator for everything. So I'm going to say 3 to the negative 2x minus 5 times 3 to the 2nd, right? That's what 9 is, to the 3rd is equal to 3 to the 1/2. Okay, Still seems kind of like not great, but we're still going to continue with this. So 3 to the 2x minus 5 times 3 to the 2 times 3, so that's going to be 6, is equal to 3 to the 1/2. Okay, combine these together, so common bases, we're going to add the exponents. So we're going to say 3 to the negative 2x minus 5 plus 6 is equal to 3 to the 1/2. Now, since these two bases are the same, we can say that this quantity is equal to that. So we're going to say negative 2x plus 1 equals 1/2. So let's subtract 1. Let's subtract 1. So I get negative 2x is equal to negative 1/2 between those two. And then divide everything by negative 2, so that gets us x is equal to 1/4. If you're not sure how to do that, right, so we're doing negative 2x is equal to 1/2. And we can divide by negative 2, or we can multiply by negative 1/2. So, and this was also negative. So negative 1/2, negative 1/2. So negative 1 times negative 1 gives you positive 1. 2 times 2 gives you 4, so it would be 1/4 is equal to x. And the last problem on this page, same deal, condense those. So it would be x plus 3, x minus 2, by multiplication, log base 6 is equal to 1. So I'm going to FOIL all this out, so I get x squared plus x minus 6 is equal to 6 to the first power. Okay, bring the 6 over, so I end up getting x squared plus x minus 12 equals 0. So that'd be x plus 4. X minus 3, when I factor, is equal to 0. So x is going to be equal to negative 4 and 3. But remember what I talked about before. If you end up having a negative value inside the log, it's not going to work. So if you end up using negative 4, that's not going to work at all. So 3 is going to be your real solution. Thanks for watching. I'm going to continue the rest of the videos down below. You could probably click one of the links from there. And thanks for watching.